Now we are on to lesson 5, and in lesson 5, it's more like a game that we're going to be playing. And what we have to do is we have to decide, is it going to be an exponential, a quadratic, or a linear function? And it's really about that easy. So what we're going to do is we're going to look at tables for each of these, and we have to determine whether the data in the table can be modeled by a linear function. To be a linear function, then we have to find that the differences in the x values are constant, and then we look at the first instances of the y. So remember when we find slope, this is pretty much what this is. We're just going to be finding slope, but all we need to make sure, the only difference with slope compared to this is that we have to make all the x values go up by the same amount or go down by the same amount. And then we're going to look to see what does the y value do, okay? So that's all we're doing. So we're going to notice that this goes up by 1 and up by 1 and up by 1. So that is constant. It doesn't even have to be the same number, it just has to be constant. Okay, so this goes up by the same amount every time. Yay, check, we've done that one. Then the second thing we have to do is we have to find out, does this go up a constant amount? Okay, so to go from -1 to 1, what did I do? Well, I went up 2. Do I go up 2 from here to here? Do I go up 2? Do I go up 2? And we don't even care what the slope is. All we want to care is if this number is the same every time, and this is a constant amount, then we know this is a linear function. And this will make more sense when we get to the next problem. It's the first difference. What is this difference right here? Okay, if it's the first distance, or the first difference, then it's going to be a linear function. Okay, that will make more sense as we go to the next one. Now, if it is a quadratic function, then it's going to be the second difference. So let's double check to make sure we can even use this method. Does this go up? Does the x value go up by the same amount every time? Yes, it does. It happens on this one to go up by 1. It doesn't matter as long as it's the same thing every time. Okay, so let's look. How much does it go up here? What does it change? Well, that goes up by 6. Okay, this one goes up by 10. And this one goes up by, oh, I always forget this one, 33 minus 19. Goes up by 14. And then what does it go up here? It goes up by 18. Okay, so obviously this is not a linear function because these values are not the same. So what this means by a second difference is we have to do it once again. We have to find out the difference here. So that goes up by 4. What does it change by here? Goes up by 4. What does it change by here? Goes up by 4. So when it is a second difference, it is a quadratic equation. Quadratic function. And I will tell you right now, on the practice exam for EOC, they want you to determine what kind of function you have, if it's linear, quadratic, or exponential. Okay, so if I go through it the first time, and it's not the same, but I go through the second time it is, then it's a quadratic function. Okay, so it looks kind of weird, seems kind of weird. And if I would graph a quadratic, what do I have again? That's right, I have a parabola. Good. And the last type we're going to look at is an exponential. Now with an exponential, okay, we still have to make sure this goes up by the same every single time. Okay, don't write this, just watch. Does this go up by the same amount? Well, that goes up by 1. This goes up by 2. This goes up by 4. This goes up by 8. Okay, so it's obviously not linear. These are not the same. And what you can do is you could check to see, is it the same here? Well, that goes up by 1. This goes up by 2. This goes up by 4. So is this the same amount? No, it is not. So this one is neither linear nor quadratic. Okay, so what we have to do instead is we have to look at the ratio. How does it change as far as a ratio? So when we're looking at exponential, we're going to look at the ratio. What do I do to this one to get this one? Well, here I multiply by 2. And it has to be the same. Can I multiply by 2 here? Do I take 2 times 2? What if I take 4 times 2? Does that give me 8? And does this give me 6 multiplied by 2? So what we do is we actually take the second divided by the first. That should sound familiar. That's a geometric sequence, right? So we're going to take this, and we can take any one. Let's take these just to be obnoxious. I'm going to take 8 divided by 4. Does that give me 2? Yes. So if you don't see what you're multiplying by, this is a better way to do it anyway. Take a term, divide it by its previous. So ratio, geometric, sequence, do you see how all this connects? Great. So that's how it has to be a ratio, and it has to be the same ratio. Then it is an exponential function. Good. Now it is your turn. Now for some reason they make the x, now they do a horizontal. So we have to look to see, does this go up by the same amount? Yay! So that means we can use this little trick that we're going to do. Now we're going to see what happens here. What do I do from negative? And you always, the order that you want to do this is look to see if it's linear first. So go through and find the difference. Well, what did it go here? Well, it went down by 3. Does it go down by 3 to go from negative 5? No, it goes down by, what is that, 9? And then we go down by 15. And we go down by, I'm not even going to try that. We go down by 21, okay? So that's not a linear. Is it an exponential? I'm sorry, is it a quadratic? So you always check for linear first. It's not, so go one more time. What's the difference here? Well, that goes down by 6. What's the difference here? Goes down by 6. Goes down by 6. What do we have, people? That's right, we have a quadratic. And if we were to graph this, this would be a parabola. So that is a quadratic function. Okay, so you always check for linear first. Okay, actually, you have to check for x first. Make sure it changes by the same amount. So here we go. Does it change by the same amount? It goes up by 1. Well, that makes it nice and easy, so I don't have to worry about there. So let's look to here. What does it go up by? It goes up by 8. What does it go up by here? It goes up by, I have to subtract. It goes up by 24. Okay, not looking linear, obviously not linear, but let's do one more so we can see if it is a quadratic. Now we have 108 minus 36, and that's 72. These are some pretty big jumps. So I'm guessing that it's not going to be quadratic, that it's going to be exponential. Let's find all of them so that we're just sure. Okay, and this one goes up by 216. Yeah, that's looking like it's going to be exponential. Definitely not linear. Okay, let's go up one more. What does it go up by here? So 24 minus 8 is going to be 16. 72 minus 24, is that 16, people? No, that's 48. So we know that it's not linear. We know it's not quadratic. So that means it's probably exponential, but they will trick us. They will give us things that are neither, none of these. So we have to check. Does it go up by the same ratio? Well, here I'd multiply by 3. Here I'd multiply by 3, and if that doesn't make sense to you, then take it right here. Just take any two terms, it doesn't matter. And take 108, divide it by its previous term, divide it by 36, and we get 108 divided by 36, and I bet you we get 3. We do, we get 3. So what is this? That's right, it's an exponential. Now they are going to ask you sometimes, like, what is the ratio? So here's my ratio. Or they might ask you on a quadratic, what is the difference? What is the second difference? So you would say a negative 6. Now you will actually have some homework problems I was looking at that it might not be exactly 3, but they're going to say it's approximately. So you're going to go with what it's approximately, and those are drop downs, so you'll be fine. But I just want to warn you, they'll do that in your homework. So the next thing they ask us in this lesson is they're saying, okay, so we have all these different functions, quadratic, linear, exponential, all this other stuff. When is it going to exceed? So when will the population exceed? When will the population exceed the other ones? So you take these three functions, and how do you think we could find that out? Maybe Desmos. It's right. We could go and graph it. Now, the book teaches that you can go and make a table, which you can, and if you all had graphing calculators, I'd do that. We don't. So I would go out to Desmos, and that's what we would do. Go out and find out when these are the same. Okay, and we're going to do that on this one and then also the next one. So let's everybody go out to Desmos right now. So out in Desmos, we're going to put these three functions in that are on your paper. I'm going to actually type in f of x. So, well, I would. No, dang, I don't have that. So you have it on yours because you have a keyboard in front of you. My computer does not, the way I have it in tablet mode. So I'm just going to do all three of them different ones. So I have y equals 3.2x. That is your f of x. Hey, maybe I should actually put an equal sign in there. Y equals 3.2x. So there's our first one. The red one is f of x. And I'm using y because I don't have a keyboard. Y is equal to 0.25 x squared. There we go. We might have to zoom out on some of these things. And then our last one, y is equal to 2, well, isn't this fun, exponent, parentheses, x minus 5. How fun is that? Okay, and then ending parentheses. Okay, so let's move our graph so we can actually see where it exceeds. Okay, so what we're looking at here, and I bet you it won't show up on mine, but I'm going to try to make the point. So here they intersect the first two, the red one and the green one, sorry, the first and the last one, they intersect here. But above that is where they intersect up here. It looks like about right there. And we're not going to be exact on these, but I'm guessing that's really close to where they intersect. Okay, is about right there. So where does one exceed the other? So on this one, we're looking at where does this blue one, because the green one's out of the picture now. The green one's out. So which one's going up faster? It's going to be that red one. Okay. So I misspoke before. I had to look back at the original problem. City C, so I'm back on your notes for a second, then we'll go back to, they want to know when does city C exceed? That is your h of x. When does that one exceed the other two? Okay, so go back to Desmos again. So all they want to know is when does y equal 2 to the x minus 5? And that's going to be your green line. When does it exceed it? It exceeds it right here. Okay, and so that's going to make the difference. Where does it exceed it? I would have thought it would have been up there, but what do I know? Okay, so anyway, let's look at the next one. So now we're going to take these three functions and we're just going to graph them and we're going to find out when does h exceed g and f. Okay, let's go back out to Desmos and graph these. Okay, so here we go. We're going to do f of x, and I wish I could type right now, but I cannot, so I'm going to have to call f of x is going to be the purple one. So that's going to be the purple. Okay. Then our next one is y equals, this is where function notation is so awesome, 2x squared plus 3. That's going to be our black one. Okay, and what we want it, for me anyway, is black, so pay attention. If I were you and you have a keyboard, type in f of x instead of y. Okay, and then we have y is equal to the x power. Oops, I forgot to make it to the x. Okay, so we want to know when does the red one, when does this red line exceed the others? We're going to actually go back in. When does the red line exceed the others? Okay, so right here is where they are the same. What is that point? So black has already been left behind. When does red exceed them? And red exceeds them right here. And that is the point. It looks like 13, so 3.17. So we would say, round that off a little bit, but you can get the idea. So it would be above the 3.717. But a lot of times we would just say that point right there, like 3.7 and 13.2. So let's summarize. And the essential question does that. How can you determine whether a function is linear, exponential, or quadratic? Okay, so linear, if it's going to be a linear, you're going to find the first difference. Okay, and what does that mean? It means that you're going to find out how does y change? What is the change in y? If it is a quadratic, you're going to find the second difference. So first you're going to go find the change. So first, find the change in y, and then do it again. Now find that change. Okay, so find the difference between each of those. And usually that's what we do. We first check to see if it's linear, because that one's pretty quick. If it's not linear, then we usually check to see if it's quadratic. If it's not quadratic, we check to see if it's exponential. And this is going to be a ratio. Okay, what do I multiply every time on the y values? Now, an important thing you need to remember is that x has to be constant. X has to be constant. It doesn't have to be 1, but it has to go up in a constant amount. So always check that first. Otherwise, you can't do any of these other things here. Now, number 4 asks, what is this, linear, quadratic, or exponential? So first check, of course, is x constant? Does it go up by the same amount every single time? Yes, this one happens to go up by 1. Okay, now let's see what happens. Okay, we first check to see if it's linear. Does it change by the same amount here? -2 to 1, that goes up by 3. From 1 to 10, that goes up by 9. From here, it goes up by, what is that, 15. And here it goes up by, didn't we do one like this already? Okay, it seems like we did. Subtraction. 46 minus 25, is that 21? Goes up by 21. Okay, so it's not linear. We can eliminate that. So let's do the next level up. Does it go up by 6? Goes up by 6. We did do this one. Okay, so this one's a quadratic. Sorry. So I looked back in the notes. We had not done number 4. It just coincidentally was the exact same differences every time. Okay, here we go. We're going to decide if this is linear, quadratic, or exponential. So let's look at our x values. Does it change by the same amount? Goes up by 1, up by 1, up by 1, up by 1. There we go. So we can use this. If that is not true, then you cannot use it. So you've got to check for the x first. Even if not, you're going to use it for anything. Okay, so here we go. Check for linear. Goes up by 5. Goes up by 5. Are you serious? Goes up by 5? Yes, goes up by 5. What is this? This is a linear. Okay, good. Okay, that's it for notes. So please go out and work on the 8.5 practice assignment that's posted for you in Schoology. Thank you so much. And if you have any questions, you know where to find us.